Algebra students, you should know how to graph any equation that looks like this. Y equals ax squared plus bx plus c. A will always exist. It will always be a number that's not 0. Because if a was 0, we're back to y equals bx plus c, and that's a linear function, which you know how to graph from earlier in the year. But you also might want to be thinking about, well, what happens if it's y equals ax squared plus bx, so in that case c is 0, or the ones that we've also practiced, y equals ax squared plus c, that's where b is 0. All the rules apply. A tells you a couple things, whatever the number is. Tells you up or down, tells you a vertical stretch, a vertical shrink, or no stretch at all. X is equal to the opposite of b over 2a, and that's the x-coordinate of the vertex. You plug that into your equation to find the y-coordinate of the vertex. From the vertex, you can do a couple things. If you know the vertex is down here and you know the y-intercept is over here, you can use symmetry to find the other point and graph. You can also use the a value to go over 1 and up a, or over 2 and up 4 times a, over 3 and up 9 times a, over 5 and up 25 times a, back 10 and up 100 times a. I hope what you're seeing is as I move from the vertex, a number in the x direction, I go up that number squared times whatever a is. So if I go over 1, 1 squared is 1, and 1 times a is a. If I go over 2, I'm going up 4a. If I go over 5, I'm going up 25a, because 5 squared is 25. Good? That will come in handy when we graph our next type of quadratic, and that's a quadratic that looks like this. Y equals a times parenthesis x minus h quantity squared plus k. This is called vertex form. Notice that the letter a is still there, and that's because whatever a is here, it will be the same if you multiplied everything out and got this of a different form, ax squared plus bx plus c. H is a new variable, and it stands for the horizontal shift. K is the vertical shift. I don't know why they use K. It doesn't really matter what we use, but it's what we use out of habit, so H and K. This is a really nice form of a quadratic. It's called vertex form. And what's really nice about vertex form is the vertex will always be the coordinates h comma k. So you already know the vertex from this form. So graphing of this form, it's much easier to use the a value to graph. So let's look at a couple examples of this vertex form. If I told you y was equal to 3 times parenthesis x minus 2 quantity squared plus 1. What you would do is you would compare that to y equals a times x minus h quantity squared plus k. And the first thing I want you to do is figure out what every variable in this vertex form is. A is 3. It's the number in front of the parenthesis. Because it's positive, it opens up. And because the absolute value of it's bigger than 1, I know I have a vertical stretch. H is the number, x minus h. This says x minus 2, so h is positive 2. K is the number after a plus, so plus 1, so that means k is 1. What I can do right now is I can graph this quadratic by going to the vertex, which is positive 2, comma positive 1. Drawing a little horizontal line, a vertical line through that vertex and a horizontal line through that vertex. And now moving from this vertex over 1 and up 1, 2, 3. 1 squared is 1. 1 times 3 is 3. Back 1 and up 3. If I were to go over 2, I would go over 2 and up 12. 2 squared is 4. 4 times 3 is 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's a little symmetry there. Back 2, negative 2 squared is 4. 4 times 3 is 12. So a couple things I want you to see from this graph. It has that vertical stretch. It opens up. And I figured out that this point is up 12 from positive 1. So what's the y-intercept? It's 13. Well, let's do a little math to figure that out. What is 3 times 0 minus 2 quantity squared plus 1? We're back in our regular first unit of algebra of order of operations, parentheses first. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 times 3 is 12. 12 plus 1 is 13. We found the y-intercept two different ways. Do you see where you end up getting that 4 times 3? When you're 2 away from the vertex. All right, let's try another example. Rewatch that example if you need to, because I went pretty fast. Here's another example. Y equals negative 1/4 times x plus 5 minus 2. Sorry, x plus 5 quantity squared minus 2. Without the squared, it's just a linear function. You distribute the negative 1/4, collect like terms, find the slope, find the y-intercept. That's a good review for your final exam, by the way. So vertex form here, I'm going to identify everything that we have. A is equal to the number in front of the parenthesis. That's negative 1/4. It tells me it's down and it's a vertical shrink. The absolute value of it is between 0 and 1, so it's not vertically stretched, it's vertically shrunk. The next thing I know, and this is where it gets tricky for kids, it's always of the form x minus h. So here h is equal to the opposite of 5. It's negative 5. And k, it's always of the form plus k. So k is also a negative. It's negative 2. And now I know my vertex is the point negative 5 comma negative 2. I also know the axis of symmetry is the vertical line x equals negative 5. So if I was to graph this quadratic, I would go back 1, 2, 3, 4, 5, and I would go down 2, and here's my vertex. From my vertex, I would graph the quadratic negative 1/4 times x squared from this vertex, just dealing with negative 1/4 times x squared. What most kids will do is they will go over 1 and down 1/4 and back 1 and down 1/4, and that's not wrong, it's just not a great point to pick. Because, 1/4 is not great. What I'm going to do is I'm going to choose a value of 4. You could also pick a value of 2, and we'll talk about why you could pick a value of 2 in a second. I'm going to choose a value of 4, so I'm going to go over 4. 4 squared is 16, and 16 times negative 1/4 is down 4. So if you go over 4, you'll go down 4, and if you go back 4, you will also go down 4. Notice I'm using that symmetry across the axis of symmetry. Another nice value is 2, and 2 works because if you square 2, you get 4. So 2 squared is 4. 4 times negative 1/4 is negative 1. So I get a negative 1 here, and I get a negative 1 here, and I have this vertical shrink, and it's also opening down. Good? If I wanted to find the y-intercept, I'll tell you it's not a nice value, but I can find it. I plug in 0 here for x. When I plug in 0 for x, I get 0 plus 5, which is 5. 5 squared is 25. 25 times negative 1/4 is negative 25/4, almost negative 6. Then I'm going to subtract 2. And almost negative 6 minus 2 is, a little bit bigger than negative 6 minus 2 is a little bit bigger than negative 8. So negative 1, negative 2, 3, 4, 5, 6, 7, 8, 9 is here. This is the value right here where it crosses the y-axis. This is getting a common denominator, negative 8 over 4. Negative 25 minus 8 over 4 would be negative 33 over 4. It's a little bit smaller than negative 8. I say smaller than negative 8 because it's more negative than negative 8. It's between negative 8 and negative 9. You don't need to find the y-intercept. You do need to label your axes, but you should have some nice points. So see why I picked 4 away. If you wanted to actually plug this value in, which is negative 1, Look what happens when you plug in -1 here. -1 plus 5, you get +4 in the parenthesis. Look what happens when you plug in this value, which is back 4 from -5. When you plug that in, it's -9. -9 plus 4, or sorry, -9 plus 5 is -4. So this value, even though it's -9, it's acting like -4 in the parenthesis. This value, even though it's -1, it's acting like +4 in the parenthesis. So you might want to watch this video again. I tried to make it short, but it's a lot of important information. So quick recap, we have two different types of quadratic functions right now that I want you to be able to graph. One is called general form. The other is called vertex form. What's interesting is that all quadratics can be written in both forms, and so the a value here is the same a value over here if you have the same quadratic. We'll talk about switching forms in another video, but for right now what you need to know is that any quadratic that looks like this could look like that and vice versa. This is called standard or general form. This is called vertex form. There's different information for each that you need. I've talked about both the kinds of information you need for this at the very beginning of the video and for the last two videos. I talked about the information you need for vertex form in this video. Please, please, please re-watch the video. It will be important because you've already watched it at 2 times speed. Re-watch it now because it's a lot of good information. Have a good weekend. Peace.